Hello, everybody, and welcome. My name is Mr. Nelson, and I'll be working with you through Chapter 9. So we're going to be learning about angles and the Pythagorean theorem, a little bit of geometry here. Now, as we take a look at this introduction sheet, it says this chapter focuses on several important geometry concepts. And so when we see the word geometry, we're thinking all about angles, and we're thinking about intersecting lines and shapes, and so much more. And so we're going to start off by investigating several concepts in this chapter, and we're going to learn even more about them in the future. So we're going to start off here with chapter 9.1, and this focuses on angle relationships. So maybe it's like, how is this angle here, x, related to this angle here, y? Well, we know that they are a straight line, meaning they add up to 180 degrees. And so that's just an example of one angle relationship we might see. Then we're also going to be looking at triangles. And maybe we're going to have missing angles within that triangle. For example, if I know this angle here is 50 degrees and this angle here is 40 degrees, then what would the missing angle here be? All right, so we're going to use a little bit of algebra as we're trying to find those missing angle measures. So without further ado, let's take a look at some of the key concepts here. It says we're going to find the measurements of missing angles made by a line that intersects parallel lines. And that may sound a little confusing to start. But parallel, just remember, parallel bars, they're bars that are side by side. Parallel parking, those are cars that are side by side, but they're never touching each other. Parallel universes, they never cross. So parallel lines are going to be going on forever and ever without touching each other. And sometimes we have a line that intersects them. And so now we have all these different angle measures created here. And we're like, what is this measure? And what is this measure here? And what about all these measures on the inside? So that's what we're going to be taking a look at. And then we're going to be looking at triangles, Pythagorean theorem, which is related to triangles. Some of you have maybe heard of it. Right triangle, a squared plus b squared equals c squared. So a lot of fun stuff. So let's go ahead and dive right into it. All right, so I have my book here and I have my little note page. And so what I'm going to start off by doing is going over to chapter 9.1.1, and that's going to be my first activity here. So as I zoom out from my screen, I'm going to see the tabs on the left side, and I'm going to click right here on 9.1.1. If you have a textbook, this would be a brilliant time to get it out. And if you have your notes, like your 9.1.1 resource page, again, now is a great time to get that out. So it starts off here talking about parallel line angle pair relationships. And again, that sounds like a mouthful, but it's going to be kind of clear with these diagrams what we're talking about. So it starts off by talking about parallel and perpendicular. And it gives us a little diagram here of parallel lines that don't intersect. And then we have a perpendicular line, which are lines that intersect and make 90-degree angles. But I went ahead and included some visuals over here of, first off, parallel lines. All right. On a football field, we see that those lines don't intersect or touch each other. They're all distanced 5 yards apart from each other. And then we see in swimming, we have our own lanes, same with track. And we don't cross over into the other person's lanes because those lines are parallel to each other. And then we have perpendicular, and that's 90-degree angles created by intersecting lines. And so here, in this example up top, we have a tennis court, and when we have our service line intersected by our midway line, we see that we are creating 90-degree angles here. So perpendicular angles are created on tennis courts. You'll see them on baseball fields, pretty much any sports court. And then we also have perpendicular lines shown here on the Google Maps map view. And this is if we have intersections, meaning roads that cross over other roads. We have 90-degree angles, again, created by these crossing roads. And so that's parallel and perpendicular. Hopefully that helps a little bit. And this is where it gets to be something new for us. There's a word called transversal. And transversal, that's talking about a line that intersects two parallel lines. So one more time, if we're talking about parallel, it's going to be these lines that don't touch each other. They'll go on forever and ever, and they'll never touch. So this is our example of parallel, shown here in figure 1. And then over here we see two lines that would touch each other if we were to extend them. So here I'm extending the lines, and we notice they cross each other right here. So this here's an example of something that is not a transversal, because a transversal is when